Okay, for this problem, this is a brief little thing about composition of functions. So that's what we're showing here. We're given f and g, and we're going to write down the composition. So here I have f of g. Well, if I write down, here's f, what I'm going to put is g inside when g is the square root of x. But f is what? Well, I'm going to write down what f is by replacing x by these parentheses. Okay, so f is parentheses divided by parentheses squared plus 1, where the parentheses is x. But I'm going to replace x by these square root of x. And then, yeah, sometimes it's a challenge to determine how much we should simplify, but I feel like this one, it's pretty clear that radical x, when I square it, makes x. So we just get that. For the next one, I'm doing g of f. Well, so I replace inside of f of x, I have g of f of x, I'm going to replace f of x by the formula x over x squared plus 1. But then g is square root of everything inside. And what do I put inside? The x over x squared plus 1. If I make a mistake, please speak up. Otherwise, the video is sort of like just, you have to throw it in the trash. So, any questions about that? So I'll try to figure out mistakes before I finish up the video. Any questions? I'll zoom out so you can still see that as I start the next one. All right, here we're going to find the distance between these 2 points. Well, for this distance, I talked a bit about how you find this formula, but at this point, I'm just going to write down the formula. And what you do is you take the change in x squared plus change in y squared. I like to write it also as d equals the square root of delta x squared plus delta y squared. Delta x and delta y are the changes in x and y respectively. So this is about plugging in numbers and actually, well, it's trying to get everything straight, or not straight, just organized, so I don't make a mistake in all these numbers that are lying around here. I take the difference of the x's. I have this idea, if I highlight it might be easier to see, but maybe not. The -3 minus 1, I square that, 2 minus 0 squared. And so that gives the square root of -4 squared plus 2 squared, which is the square root of 16 plus 4, which is square root of 20. Okay, now notice it's not the square root of 16 plus the square root of 4. We cannot break up a radical over addition. You cannot do that. But we have square root of 20. And then somehow, times table is more or less maybe the answer, is you figure out the 20 is 4 times 5, and 4 is a perfect square. So our final answer is 2 radical 5. All times tables. Not acceptable are decimal approximations. So we want exact answers, not a decimal approximation, because square root of 5 is an irrational number. So any sort of decimal would be an approximate, a rounded answer. So don't want the rounded answer. The next one, maybe not enough space, but maybe, we're going to find the midpoint between these points, -1, 3, and 6, 5. And so we're using the formula. The formula is this. Well, we're going to write the midpoint by putting a bar above. We're going to write x bar, y bar. X bar and y bar are notation that you'll see sometimes for average. And that's what the midpoint is. It's the average of the x's, x coordinates, and the average of the y coordinates. So, I mean, okay, the midpoint is to say the midpoint of the average is the average is not really quite correct, but the coordinates are the average. The coordinates of the midpoint are the average of the x coordinates, the endpoint, and the average of the y points, and the endpoint. So I have -1 plus 6 divided by 2, and 3 plus 5 divided by 2. So when I wrote up the problem, for whatever reason, I didn't try to avoid fractions. Okay. Are there any questions about that, or are you going to point out that it's mistakes or anything? Oh, I didn't turn my video on. Sorry about that, everybody. You don't get to see me, so it's not as much fun. Okay. Anyway, so I'll keep that there and we'll move on. For the following, this is another exercise. Use the table to answer these questions. This is another example of composition of functions. And some people might say, yeah, I'm super into this table. But some people might say, sort of think the table's confusing, but let's just deal with it anyway. That's the way, I think that's how it happens sometimes. So the top is X, and then the next two rows are the Y values for F, and the next row is the Y values for G. So the first one says, what's F of G of 6? Well, I need to figure out what G of 6 is. So I'm going to just make a mess of this thing. When X is 6, I'll put this vertical bar. When X is 6, G is 7. Now, if we don't get that part, then we better stop right there. So what I'm saying here is that G of 6 is equal to 7. And let's see, did I do that right? Okay, does anybody have a comment on that? See where that's coming from? Then I do the next one, and I do X is 7, and F of 7 is equal to 1. Oh, okay. Actually, I can sort of recycle this line. For this one, I need to find F of 6. F of 6 is 2. And then I need to find G of 2. G of 2 is equal to 6. All right, so this is G of 2 is equal to 6. Okay, what do you think about that? Do you have any questions for that whole page, maybe even? Any questions there?